Hello again. This video is going to talk about the tide worksheet. So we will take a moment to do this warm up prior to that. So if you were in class or you're going to be in class, we will actually do this warm up at that point, probably on the second day of the word problems or word problem applications. But so you can fast forward if you plan to be in class. But if you're not in class, then I would encourage you to pause the video and work through this warm up. The answer you should get for this is y equals 15. This is one of the answers. Cosine of pi over 25 times x minus 15 plus 10. There are definitely others that you can get, but you should, if you didn't get that, amplitude is high minus low divided by 2. So 30 divided by 2 is 15. Vertical shift is high plus low divided by 2. So 20 divided by 2 is 10. And the b value is going to be 2 pi divided by the period. And the period, if we go from, I decided to write the equation for this cosine graph. So from 15 to 40, 40. If I take 40 minus 15, I get 25, but that's just half a cycle. So I have to multiply it by 2. So 2 pi over 50 would be pi over 25. So if you had pi over, let's see, if you had 2 pi over 25, then that's your error there. So then I shifted it right 15, and then it had the vertical shift of 10. You could have done a negative cosine graph if you said negative 15 cosine and then x plus 10. That would have worked. That probably would have been the easiest for those. Okay, so on the tide worksheet, basically what we're doing again is we're applying some knowledge here. So we're going to do a little bit of this together, and then you're going to be expected to do a little bit of it on your own. So if we look at that worksheet, it says many natural events have a pattern that repeats over a period of time. These events can be described by sinusoid curves such as y equals a sine and then the quantity of b times the quantity of x minus c plus d. Now, a sinusoid curve can be a sine or a cosine. So it says such as that one. So it could also be a cosine graph. So it says the data from problems allow us to find the coefficients a, b, c, and d. So we're going to talk about Jesse and Tanya. And what I would encourage you to do is up kind of in the top right-hand corner of this, there should be a little bit of room to where we can just draw just a simple sketch. And we're going to end up sketching it in more detail here on number 5. But just for us to get an idea of what's going on. So it says, Jesse and Tanya dock their sailboat in an ocean area named Rockport. Their boat reaches 1 meter below the waterline. They carefully watch the tides to determine their sailing times so they will not run aground. At 10 a.m., the water is at high tide. The depth of the water is 1.5 meters during high tide and 0.7 meters during low tide. Low tide occurs at 6 p.m. Since this behavior is periodic, they decide, why not, to write an equation to predict the sailing time. So we're going to help them determine the coefficients so that at the end we can figure out when they can go sailing and not hit the rocks in Rockport. So I want to figure out what our axes are. So if we notice, we have 10 a.m. and 6 p.m. So we're going to have to use military time. So we're going to say hours after midnight. That's going to be important. It's going to be important in your answer as well. So hours after midnight is going to be our x-axis. And then the y-axis is going to be our depth in meters. So I guess the x-axis would be our time. Be a little more specific in hours after midnight. You could just write hours after midnight and that would be fine with me. So we want to recognize that their boat reaches 1 meter below the water line. That's going to be important. So if we think about the surface of the water, when you get in a boat, you're going to go down below the water line. So we got to at least have 1 meter of water. Otherwise, they're just going to be sitting on rocks and not be able to be buoyant and sail there. So we see that at 10 a.m., they're at high tide and the depth is 1.5. So we're not going to make a scale here. We're just going to say at 10 a.m., 10 hours after midnight, they're at high tide, which is 1.5. So we can make a mark here that at 10 hours after midnight, we're at 1.5 meters. And then it tells us that at 6 p.m., they're at low tide, which is 0.7. So somewhere around here, they're going to be at low tide. So we want to figure out what that number is. Well, it's 6 p.m. So 6 p.m. would be 18 hours after midnight. So 12 and 6 is 18. So what we notice is we have gone from a high to a low. I'm actually going to scoot those a little closer together just so it makes it easier for me to graph this sinusoid. I'm going to scoot my mark over, and it'll give me a little bit more room on here. So what we have is we have a high to a low. Now, we know that that is not a full cycle. We know that to get the other part of the cycle, we're going to come back up, and that's going to give us a cosine graph. So we need to figure out what that second mark is. Well, obviously, low tide occurred 8 hours after high tide. So if we go 8 more hours, 18 and 8 would be 26. That's going to be important here. So you should be able to go through based upon that information, and you should be able to answer 1 through 4 without really any issue. Okay, something that we've done before, no problem there. Okay, should not have any issue with that. So I'm going to have you do that so that ultimately you can write equation for number 5. So number 5 says to use the values that you calculated for A, B, C, and D and your graphing calculator to draw the graph of the function. Now I do want you to notice it says y equals a sine of B and all that, but that can actually be cosine. You can write a sine or a cosine equation. Okay, I would encourage you to write a cosine equation because that's what I'm seeing up there. I'm seeing cosine. If you want to do the extra work to write a sine equation, that's fine. Okay, and we're going to not have degrees on the x-axis. So we're going to write this in radians, although you could put it in degrees, but we're going to make sure we're in radians. So then we're going to look here on 5, and we're going to extend our graph to fill the entire coordinate plane. So I'm going to go ahead and do that with you and then talk about number 6 there that you're going to do. Okay, which I'm going to write in here. So on the x, we're going to go, it says from -1 to 24, and we're going to go by 1. So you don't need to write all these in, but it's just showing how far we want to go. And I'm going to go, you can even go a little bit past 26. So I'm just going to count 1, 2, 3, 4, 5, and maybe just mark some numbers so that whenever we start to graph these, we have some reference points. So this is going to go out to 25. And then on the y-axis, it says go from 0 to 2 using 0.3. So 0.3 would be our first mark. So then we have 1.2. Actually, I'm just going to go ahead and write 1.5. So 3, 6, 9, 12, 15. So 1.5. So based upon what we had from the start, we know that at 10, we're at 1.5. And we know that at 18, so 15, 16, 17, 18, we're at 0.7. So 0.3, 0.6. So 0.7 is we're going to be just barely above 0.6, goes 369. So again, we're going to mark those. So 10 is at 1.5. So then at 18, we're at 0.7. So we can draw that in. So there's part of our cosine graph. So we can come back the other way. Since that was 8 units, if we come back 8 units from 10, we'd be at 2. So at 2, we're going to be at 0.7 as well. It's hard for me to write that small here. So 2 is 0.7. So we have this part. And based upon what you did from number 2, you're also going to find the vertical shift. Okay, so that can kind of help you know a little bit about what's going on. But we can kind of see what's happening here. If we were to go 8 more, so if we were to go to -6, so back here to -6, we would be back up to 1.5. So it's just trying to get us to see more than one cycle here. So we would have something to look like that. And then obviously if we go out here to 26, we're also back up to 1.5. And we talked about that up above. Oh, battery's getting low. Okay, so we were able to just see more of the graph. Now, when we look at number 6, it says, according to your graph, at what time intervals can Jesse and Tanya sail without hitting the rocks in Rockport? It says, hint, add the auxiliary line y equals 1 to your picture. So what I'm going to ask you is just to give me the first time interval. There's more than one. I'm going to ask you to give me the first time interval where they can sail. So remember, an interval means from here to here. So you don't have to give me every one. So the idea is that they have to have 1 meter of water. Remember, the y-axis is meters. So 3, 6, 9. So just above here would be 1 meter of water. So if we drew in this auxiliary line at y equals 1, we know that at midnight they are below that auxiliary line. Okay, you can't really tell where it is. You could find it on your calculator, but they're below the 1 meter line. Okay, they do not get to the 1 meter line until you get right here. And then they are above the 1 meter line. So we need it to be above there. And then you see all the time above, and then they come back. Whoops, sorry about that. They come back, and at this point in time, they're going to then hit the 1 meter line and then go below it. So the first time interval is between those two kind of pinkish points that I have. So you need to find those. You should know how to do that. There is a Schoology assignment where you are going to enter that information. So you're going to give it to me in 2 different formats. You're going to give it to me in hours after midnight. So you're going to say, 3.28 to 7.59 hours after midnight. So you're going to round to the nearest hundredth. And then you're going to give me the actual time. So remember, if I had something like 3.5 hours after midnight, that would be 3:30, because 0.5 is half of an hour. That doesn't mean 50 minutes. It means half of an hour, and there's 60 minutes in an hour. So you're going to have to do some converting from a decimal time, okay, knowing that there are 60 minutes in an hour to get the actual clock time. Okay, so you're going to give me that, AM or PM. So you're going to enter those. You're going to have, I believe I have it set at 5 attempts in Schoology. So if you get a few and you don't get it right, you probably want to ask me for some help on that. Giving those attempts so that we can get that correct. And then you're going to move on to the word problem worksheet. So on the back of the Tide worksheet, you have 1, 2, 3, 4, 5. So there are 5 different pictures. Some of them, like 3 and 4, and actually 2 and 5 are partials. Some of them are graphs. They're graphs of the situation. Number 1 is a sketch of the actual diagram that's used for the problem, but it's not an actual graph of the situation, but it's a diagram that will help you. But 2 through 5 either give you full graphs of the situation or a partial graph and diagram of what's going on. So you're going to want to use those on the word problem worksheet. So make sure you have that handy and you're referring back to that. But at any point in time, if you're needing help, please do not hesitate to reach out. These are some things that we're doing to apply our knowledge of trig, and things that you're definitely going to see in the future. So let me know if you need help. Be happy to do so. Have a good day.